Hi, this is the solution process for Chapter 14, Thermodynamics. We go to example 14.1, solve problems related to first law of thermodynamics. Three moles of an ideal gas expand from the volume V to 4V at constant temperature 10 degrees Celsius. Calculate work done by the gas. Heat transfer is the heat being absorbed or released by the gas. Number of moles equals to 3. Initial volume is equal to V. Final volume is equals to 4V. T is constant, so this is the isothermal process. Work done by the isothermal process is equal to N RT ln V final divide V initial. Work done is equal to number of mole free. R is the molar gas constant, equal to 8.31. T is the absolute temperature. I have to convert the temperature into SI unit, equal to 283.15 ln V final for V divide V initial V. Cancel out V, so we got work done is equals to 9.78 times 10 power of 3 joule. For question B, heat transfer. By using the first law of thermodynamic equation, Q is equal to delta U plus W. Q is the heat transfer, delta U is the change in internal energy, and W is the work done. The internal energy is depend on temperature. The temperature is constant, so that the change in internal energy is equal to 0. So Q is equal to W equal to 9.78 times 10 power of 3 joule. Question C, is the heat being absorbed or released by the gas? If heat absorbed by the gas, the sign answer for Q is positive. If the heat is released by the gas, the sign answer for Q must be negative answer. So, based on the calculation in B, you got Q is equal to positive 9.78 times power 3 joule. Positive answer. So heat is absorbed by the gas. Okay, now example 14.2. Solve problems related to work done in isobaric and isovolumetric process. Isobaric process, the pressure is constant, whereas isovolumetric process, the volume is constant. Figure below shows an ideal gas which is compressed from a volume 8 liter to 4 liter at constant pressure of 1 atm. Heat is then supplied to the system at constant volume, while pressure and temperature is let to change until the system finally reaches the initial temperature at C. Based on the PV graph, we have two processes, process A to B and process B to C. A to B is the isobaric, the pressure is constant. B to C is the isovolumetric, the volume is constant. Calculate the total work done in the above process and the final value of pressure at C. So A. Process A to B is constant pressure V, the volume at A, is equals to 8 times 10 power negative 3 cubic meter in SI unit. Volume at B, VB, is equals to 4 times 10 power negative 3 cubic meter. For process B to C, isovolumetric, the pressure at B is equals to 1 atm. And the pressure at C is equals to pressure final. So work done by the both process A to B and B to C. Work ABC is equals to work AB plus work BC. The work done by the BC process is equals to 0 joule because based on the PV graph, there is no area under the BC. So work done by the BC is equal to 0 joule. Work done by the ABC is equals to work done AB. So calculate the area under the graph AB is equals to P times delta VAB is equals to P times V, volume V, final volume VB minus initial volume VA. So equals to convert pressure into SI unit, 1 times 0.13 times power 5 VB 4 times 10 negative 3 minus VA 8 times 10 power negative 3. So we got work done by the ABC process is equals to negative 405.2 joule. Question B, the final pressure of PF. So the pressure at C lah, PC. Question B, V at B is equals to V at C because constant volume. Temperature at A is equals to temperature at C. pressure at A is equals to pressure at B. At A, by using the ideal gas equation, PV is equals to nRT. So PA VA is equals to nRTA. So we got one equation. At B, by apply the ideal gas equation, P at B, PB, volume at B, VB, is equals to nRTB. So we got equation 2. Equation 1 divide equation 2. Equation 1 divide equation 2. Because PA is equal to PB, we cancel out pressure, cancel out number of mole, cancel out molar gas constant. So we got VA per VB is equal to TA divided by TB. So 8 liter, saya tak convert volume ni to the SI unit 8 liter. So saya tulis dia punya unit liter divide by 4 liter is equals to TA divide by TB. So simplify, can derive TB is equals to 0.5 TA. Okay, at C, also apply the ideal gas equation. PC VC is equals to nRTC. PC is the P final P final. VC is equals to nR, because of TC is equals to TA. TC is equals to TA. Okay. So you can substitute TC TA. This is equation number 3. Equation number 3, divide equation number 2, PB, more to mathematics, PB, VB is equals to nRTB. Equation number 2. So, volume at C is equal to volume at B, so we cancel out volume, cancel out number of mole, cancel out molar gas constant. So substitute PB and TB, kita substitute sebagai 0.5 TA. Then solve this mathematics. We got answer. Pressure at C, iaitu final volume PF is equal to 2 atm. 2 atm is not SI unit, but we have to answer must be has unit. Example 14.3, solve problems related to work done process in isothermal. A cylinder contains 7 grams of nitrogen gas. The gas is compressed at constant temperature of 90 degrees Celsius until the volume is half. Given that molar mass for nitrogen gas is equal to 28 grams per mole. Question A, calculate the work done to compress the gas. Question B, determine whether the heat is absorbed by or released from the gas. The mass of gas is equals to 7 gram. Convert to SI unit equals 0.007 kilogram. T is constant. Is equals to 90 plus 273.5. Convert the temperature into SI unit. Got 363.5 Kelvin. Volume initial is equals to V, and final volume Vf is equals to 0.5 V. Question A. The work done for the isothermal process by using this formula, W is equals to nRT ln V final divide V initial. We have to calculate the number of mole. The number of mole N is equals to mass of gas divide molar mass M. Number of mole is equals to 7 gram divide 28 gram. Number of mole is equals to 0.25 mole. So work done is equals to 0.25 times molar gas constant R 8.31 times temperature 363.15 ln 0.5 V final divide by V. Cancel out V, and we got the work done by the isothermal process is equals to negative 522.94 joule. For question B, determine whether the heat is absorbed or released by the gas. We got negative answer for work done. So heat is released by the gas. Okay, now we go to example 14.4, sketching graph related to process in isothermal process. 1 mole of an ideal gas is compressed isothermally from volume 4V to V. The work done on the gas is equal to 4.5 times 10 power of 3 joule. Sketch the PV graph for this process. Question A. Question B. Calculate the heat transfer during the compression. Is the heat absorbed or released by the system? Question C. Calculate the isothermal process temperature. So sketch the PV graph. Question A. Y-axis is pressure, unit in Pascal, SI unit. X-axis is volume. Unit is cubic meter. So initial point is at A. Compress isothermally. The volume is decreases. Initial volume for V decreases. Decreases isothermally to B. the volume at B is equal to V. Now we go to B, question B. Question B, calculate the heat transfer during the compression. Is the heat absorbed or released by the system? Okay. Apply the first law of thermodynamic equation. Q is equals to delta U plus W. Delta U is equals to 0. Delta U is the change in internal energy. The change in internal energy is equal to 0 because T is constant. Internal energy is depend on temperature. If there is no change in temperature, so delta U is equals to 0. Q is equals to W. So Q, same answer. Is equals to negative 4.5 times 10 power of 3 joule. Why negative? Why negative? Negative answer because the gas is compressed. The gas is compressed. The volume is decreases. Volume is decreases. The final volume is less than initial volume. The volume decreases. And the work done is on the gas. The work done on the gas. Work done on the gas. That is why answer for W is negative answer. Question C. Question C. Calculate the isothermal process temperature. By using the work done by the isothermal process, W is equals to N RT ln V final divide V initial, negative 4.5 times 10 power of 3 for work done is equals to number of mole is equals to 1 times molar gas constant R 8.31, temperature T ln V final is V divide V initial for V. Cancel out V. Solve this mathematics. Got temperature is equals to 390.62 Kelvin. Okay, now we go to next question. Example 14.5. Solve problem related to change in internal energy. This is the PV graph. To process A to B. A to B is the isovolumetric process because there is no change in volume. B to C is the isobaric process because constant pressure. Constant pressure. Figure shows a series of thermodynamic process ABC during the process AB and process BC. 120 joule of heat and 500 joule of heat are added respectively. Calculate the change in the internal energy in the process ABC. So 14.5 Q, the heat process AB, QAB is equals to 120 joule, and Q heat BC, QBC is equals to 500 joule. The change internal energy delta UABC is equals to delta UAC. Ni extra knowledge dah. Why? Because initial point is at A and final point is C. The change in internal energy is depend on initial temperature and final temperature. It's not depend on the path of the process. So that is why the change in internal energy delta UABC is equal to delta UAC. Okay. Now we go to the equation for work done. Work done. Okay, now we go to the first law of thermodynamic process first. QABC is equal to delta U ABC plus W ABC. QABC is equal to QAB plus QBC. QAB plus QBC. Stop here. Example 14.5. Solve problems related to change in internal energy. This is the PV graph. To process A to B is the isovolumetric process. B to C is the isobaric process. Figure shows a series of thermodynamic processes ABC during the process AB and process BC. 120 joule of heat and 500 joule of heat are added respectively. Calculate the change in the internal energy in the process ABC. So process A to B is the isovolumetric process. The pressure at A, EA, is equals to 2 times 10 power of 4 Newton per meter square. Pressure at B, PB, is equals to 7 times 10 power of 4 Newton per meter square. And volume at A is equals to volume at B is equal to 3 times 10 power of negative 3 cubic meter. Process B to C. For process B to C, this process is the isobaric process. Constant pressure. Volume at B, VB, is equals to 3 times 10 power of negative 3 cubic meter. Volume at C is equal to 6 times 10 negative 3 cubic meter. Pressure at B is equal to pressure at C equal to 7 times 10 power of 4 Newton per meter square. Okay. The heat supplied to the AB process is QAB is equal to 120 joule, and heat supply to the BC process QBC is 500 joule. Question is calculate the change in internal energy delta U for process ABC. But apply the first law of the thermodynamic equation, Q is equal to delta U plus W. So Q ABC is equal to delta U ABC plus work done W ABC. Q ABC is equal to Q AB plus Q BC equals to delta U ABC plus, and the work done ABC is equals to work for AB process plus work done for BC process. QAB 120 joule plus 500 joule is equals to delta U ABC, the change in internal energy for ABC process, delta U ABC, plus WAB, work done by AB process plus work done by BC process. The work done by AB process is equals to 0 because area under the PV graph for the isovolumetric process AB is equal to 0. There is no area under PV graph. So just to calculate the work done for BC, the area under the graph for BC process isobaric is P at B times delta V, di mana perubahan volume ini final volume at C VC minus volume initial volume at B VB. (120 plus 500, 620 is equals to delta U ABC plus pressure at B 7 times 10 power of 4 times volume at C 600 10 negative 3 minus 3 times 10 power of negative 3. So by solve this mathematics, we got the change in internal energy for ABC. Delta U ABC is equal to 410 joule. Okay, now we go to the last example, 14.6. solve problems related to isothermal process. 0.5 liter of an ideal gas at a pressure of 20 atm to a final volume 0.5 cubic meter. The process is isothermal. Isothermal process, the temperature is constant. Calculate the question A, final pressure. Question B, the work done by the gas. So, initial volume, convert to the SI unit, we got 0.5 times 10 power negative 3 cubic meter. Final volume is equals to 0.5 cubic meter. Initial pressure, P initial is equals to 20 atm, convert to the SI unit, times 1.013 times 10 power of 5 Pascal. If we refer to the PV graph, pressure against volume graph, this is the isothermal process, initial point, final point. This is the P initial, the P final, V initial volume, and this is the final volume. Okay, question A. Calculate the final pressure. By apply the first law, by apply the ideal gas equation, PV is equals to nRT. So at initial point, P initial is times V initial is equals to nRT. T is constant. And at final point, P final, V final is equals to nRT. So equation 1, equation 2. Equation 1 divide equation 2. Cancel out N, cancel out R, molar gas constant, cancel out temperature. We get P initial, V initial is equals to P final, V final. Substitute value for P initial is equals to 20 times 10, 1.013 times 10 power of 5 times volume initial 0.5 times 10 power of negative 3 is equals to P final times V final is 0.5. Solve this mathematics. Got P final is equals to 2026 Newton per meter square. Okay. Question B. The work done by the gas. The work done by the isothermal process is the area under the PV graph. So, by applying the formula, work done for isothermal is equals to nRT ln V final divide V initial. We have no number of mole, molar gas constant is 8.31, and no temperature. So, relate to the ideal gas equation. PV is equals to nRT. Work done is equals to PV ln V final divide V initial. can use P initial, V initial, or P final, V final, because P initial, V initial is equal to P final, V final. Work done is equal to 20 times 1.013 times 10 power of 5. V initial 0.5 times 10 power of negative 3 ln 0.5 divide ln V final divide V initial 0.5 times 10 power of negative 3. Solve this mathematics. We got work done by the isothermal process is equals to 6998 joule. Okay, good luck for you all. Thank you.